Hello everyone, welcome to the second part of the video, and in this video we are going to solve 5 more problems. So our first problem is, if E and G respectively denote energy and gravitational constant, then the ratio E over G has the dimension of, and 4 options are given. So to solve this problem we need to know the dimensional formula for the energy and gravitational constant G. So the dimensional formula for energy is ml square t to the power minus 2, and the dimensional formula for G is m inverse L cube t to the power minus 2. The dimensional formula of the ratio E over G will be, so you have to just put the dimension of E, which is ml square t to the power minus 2, divided by dimensional formula of G, which is m inverse L cube t to the power minus 2. Now if you calculate the powers of same quantities, say for m, l or t, then you will get the final result m square L inverse t to the power 0. Therefore option 3 is the correct answer. So let's go to our next problem. Our next problem is, the angle of 1 minute in radian is nearly equal to, and 4 options are given. Now we know that 180 degree is equivalent to pi radians. Therefore 1 degree is equivalent to pi over 180 radians, and also 60 minutes is equivalent to 1 degree. Therefore 1 minute is equals to 1 over 60 degree, or it is equals to 1 over 60 times pi over 180 radian. So if you calculate this, then the answer will be 2.91 into 10 to the power minus 4 radian. Therefore option A is the correct answer. So let's go to our next problem. Our next problem is, the unit of thermal conductivity is. Now to calculate the unit of thermal conductivity, we are going to use the formula of rate of heat flow through a conductor of length L and area of cross section A, and it is given by dq over dt equals to K times A times delta T over L. Here K is the coefficient of thermal conductivity and delta T is the change in temperature. Now this can be rearranged as K equals to L over A times delta T times dq over dt. Now to evaluate the unit of thermal conductivity, we need to know the units of each physical quantity in the right hand side. Here the unit of L is meter, A is in meter square, delta T is the change in temperature, so its unit is Kelvin, and dq over dt is watt. Now if you put all this quantity in the previous expression, then you can find the unit of K, and it will be watt meter inverse Kelvin inverse. So option C is the correct answer. Our next problem is, a physical quantity of dimensions of length that can be formed out of C capital G and E square over 4 pi epsilon naught is. Here C is the velocity of light, G is the universal constant of gravitation, and E is the electrical charge, and 4 options are given. Now let A is the quantity whose dimension is length, and A depends on C, G and E square over 4 pi epsilon naught up to some arbitrary power of A, B and C respectively. So we can write this A proportional to C to the power A, G to the power B, E square over 4 pi epsilon naught to the power C. Now the dimension of A should be L. Now you have to put the dimensional formula for each quantity in the right hand side. So for C it is LT inverse, for G it is m inverse L cube t to the power minus 2, and E square over 4 pi epsilon naught has the dimension ml cube t to the power minus 2. Now if you calculate all the powers, then it would be L to the power A plus 3b plus 3c, m to the power minus b plus c, t to the power minus a minus 2b minus 2c. Now if you compare the powers of similar quantities from both sides of the equation, then you can write 3 equations. The first one is A plus 3b plus 3c equals to 1. Second one is minus b plus c equals to 0. And the last one is minus a minus 2b minus c equals to 0. Now if you solve these equations, then you can find the value of ABC, which is a is equals to minus 2, b is equals to half, and c is also equals to half. Therefore, the expression of the physical quantity will be 1 over c square g times e square by 4 pi epsilon naught to the power half. Therefore, the correct answer is option 4. Now our next problem is Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Which of the following has the dimension of length? So among the four answers, we have to identify the quantity whose dimension is length. Now one can solve this problem by usual method of dimensional analysis, that is by using the principle of homogeneity of dimension. Or one can solve this problem by checking dimensions of each quantity in the options given. So for this we need to know the dimensional formula for h, g and c. The dimensional formula for h is ml square t inverse. The dimensional formula g is m inverse L cube t to the power minus 2, and the dimensional formula for c is L t to the power minus 1. Now let's consider the first option, that is square root of hg divided by c to the power 3 by 2. So if you put all the dimensional formula of h, g and c, then you will find that it has the dimensional formula of L. Therefore, option A is the correct answer. And you can also check the dimension formula of other quantities given in the options, and you will find that they do not have the dimension of length. So that's it for now. See you in the next video.